Welcome to our webinar, How Jupyter and Pandas Can Fast Track Your Analytics Effort. My name is John Hammock. I'm a developer evangelist for Treasure Data. So let's start off with a couple of questions. What is the data analysis problem that data scientists are seeing, and what is the data access problem? Anyone who wants to make sense of their data will A, need to be able to take into use the best practice for data analysis, but more importantly, be able to access their data, all of it with minimal headaches. We'll show you how Python, Pandas, and Jupyter solve the data analysis problem, and how Treasure Data solves the data access problem. So this webinar is going to walk you through the Jupyter Notebooks, a Pandas Python library, and also it's going to walk you through solving some of the typical problems associated with managing your customer analytics project. First off, this is a very short webinar, so we'll only be touching on some of the points here, just enough to get you started. You're going to learn what data science problems are important to address for analyzing your customer behavior data. What are Jupyter Notebooks and how do they work with Python? What is Pandas and why is this library great for analyzing your customer behavior data? What are the challenges associated with collecting and accessing customer behavior data, and how do all of the above work together? We'll also explore some of the typical data consumption headaches people encounter when using these technologies with large data sets and present some custom solutions for solving them. So what exactly is the Jupyter Notebook? Well, the Jupyter Notebook is a web application that allows you to create and share executable documents that contain code, equations, visualizations, and explanatory text. Well, how do they work with Python? The Jupyter Notebook is a way of embedding programming steps into a document. This is necessary because if I'm a data scientist, I want to find a way to save my steps so that I can reproduce them or hand them off to someone else. Also, I'll need to reproduce steps to test a range of hypotheses. More on these later. Originally called the IPython Notebook, the Jupyter Notebook now supports more than 40 programming languages. So if we look at the example I have on my slide, this is a simple spectral analysis. It was a submission to PyCon this year, and it pretty much demonstrates some of the main features of the IPython Notebook or the Jupyter Notebook. So at the very top we have our title, which is simple spectral analysis. We got some text. We have a link. And then embedded with latex, which is the equation for the fast Fourier transform. So more text. And then underneath, we have our first code. So this is an import statement. We're basically importing a WAV file library and we're reading a WAV file into a variable. Underneath that, we've got another explanatory bit of text underneath that. And then next, we've got another block of code. We're declaring matplotlib inline. We're importing pyplot as PLT, and then we're creating basically two figures. One is a plot of our raw audio signal, and the second is a plot from our spectrogram. So a Jupyter Notebook is a web application running as a service. This web application can run as a local web server on your machine, or it can run remotely. Team members can exchange notebooks between themselves with the IPYNB file extension, and you can read more about Jupyter Notebooks at jupyter.org. So a little bit more about Python and Pandas. Python itself is a widely used general-purpose, high-level programming language. Its design philosophy emphasizes readability of code, and its syntax allows programmers to express concepts in fewer lines of code than would be possible in languages such as C++ or Java. The language provides constructs intended to enable clear programs on a small and large scale. Pandas is otherwise known as the Python Data Analysis Library, and this is an open-source BSD licensed library providing high-performance, easy-to-use data structures, we'll see the data frame in a moment, as well as data analysis tools for the Python programming language. Jupyter Notebooks, as you saw, combined with the Python Pandas library, are quickly becoming the established de facto tools for the modern data scientist because of their ease of use, repeatability of commands, and flexibility for data explorations. So a little bit about the data access problems. What are the challenges associated with collecting and accessing customer behavior data? Well, a typical data analytics pipeline consists of a few things. Data ingestion, which means pulling the data from the source into the place where it's going to be analyzed. In some cases, this also includes data transport, which means getting the data from one place to another, transforming schemas and formats and so forth. Then there is a data storage problem. Where do I keep my data when I'm analyzing it? I need to be able to run queries, including user-defined functions for machine learning and artificial intelligence, on my very large data set to draw insights from it. I need to be able to export my query data to other systems, and last but not least, I need to be able to do visualization. However, while having all of your data in a single location is considered ideal, comprehensive analytics can only truly happen when your data is in one place. How do you achieve that with the data migration latency, schema incompatibilities, and having your data stream in from all over the place in multiple formats? Another data access problem is actually being able to query and manipulate your stored data using the existing competencies in your team. There are actually far more people in the world comfortable with SQL than there are with MapReduce. Does this mean you should hire MapReduce experts? If so, how would you deal with a disconnect between what your data scientists most likely know, which is going to be more likely SQL, and that which is required on your data engineering infrastructure? Treasure Data can help with all of the above. So, what about the data analysis problem? Data analysis includes inspecting, cleaning, transforming, and modeling data in a way to suggest actionable conclusions and to support decision making. There are many pipelines and tools available for doing this. However, my analysis is useful only if A, it is documented, and B, it can be repeatable, and finally, C, it can be controlled. Lastly, it needs to be able to be shared with others. But even that isn't the whole picture. I need to be able to do flexible ad hoc analyses of my data set. And when I reach a useful hypothesis, a conclusion, or a data model, I need to be able to manipulate my data or supporting code one piece at a time to test other hypotheses. Of course, any data or code is meaningless without context. Are there formal equations available to explain my code or transformations? Do my estimation models project relevant or irrelevant projections? Does my medium support inline text? Can I visualize data on the fly to substantiate or disprove my hypotheses or methods? In fact, data analysis looks and works very much like the scientific method. I want to be able to perform documented, repeatable, and controlled experiments with all of my data and share my examples and methods and conclusions with others. So by way of an example, what data science problems are important to address for analyzing your customer behavior data? In the case of a web, I want to know perhaps when a user clicks a button on a web page. In the case of an Internet of Things device, perhaps I want to know when a user changes a dial on a thermostat or adjusts some automotive electronics. For example, in gaming, I would like to know anytime someone wins or loses a game. Each of these is going to represent a customer interaction that triggers a piece of event data being created. Essentially, once I've created enough events across all of the entry points in my system, I can begin to analyze my data and gain insights from that data. We're going to jump right to the next point, which is my false solution. For the data access problem, a false solution usually involves not having all of our data in one place. So if data is scattered across many locations, databases, and storage media, you may have to deal with a performance aspect or spaghetti pipeline code when pulling your data from multiple remote or local formats to query for correlations. Another false solution to the data access problem would be requiring your data team to learn or be competent in a technology like MapReduce, because it first of all diverges from what a lot of people are using in terms of SQL. Secondly, knowing MapReduce isn't necessarily always necessary. It effectively decouples your analytics work from your data engineering. As MapReduce programs are essentially native and standalone Java or even Scala apps, it's not trivial for a data scientist to do exploratory queries on your data by writing native MapReduce code. One false solution for the data analysis problem would involve not using the de facto standard for data analysis. For example, if my data analysis code doesn't have context, including supporting equations or text, it won't always be possible to understand what it's actually doing. If it's not reproducible, you may have to repeat error-prone coding or exploration. Finally, if you can't hand off your complete work, then there are diminished opportunities to review or collaborate. So what about the real solution? Well, Python and Pandas is going to solve your data analysis problem. To enable more flexible ad hoc analysis of your event data, e.g. customer interaction data, Jupyter Notebooks provide an easy way to segment your analysis into multiple steps. See the result output from each step and visualize your data in pipeline in a single interface. Jupyter Notebooks also enable you to easily share the resulting workbooks with other members of your team for them to rerun and expand on your analyses. Finally, Pandas provides a syntax for performing rich customer analytics such as segmentation, cohort analysis, sessionization statistics, etc. We can get the same amount of insight for less code as compared to using straight Python. Using the data frame abstraction also improves processing performance for common analytics processing steps. Pandas provides our syntax for data science, and Jupyter provides a way to visualize our data to see the results of that data along the way. This is helpful because you don't need to go back and change the way your data is compiled at different points. Jupyter will let you do that. Finally, treasure data solves the data access problem. You can think of treasure data as a universal data connector, enabling you to connect to any number of disparate data sources, each with unique formats, schemas, and query methods. Pull the data out of them, query that data using something as familiar as SQL, and finally export the result into any other format for visualization, for further analytics, or so forth. You can also let your data reside solely in Treasure Data Storage Cloud or use Treasure Data as your primary data source. So are we ready for a demo? What we're going to do is we're going to set up our Treasure Data API key, and we're going to install Jupyter, Pandas, and the Pandas TD connector. We're going to run Jupyter, create our first notebook, we will explore our data, and we will sample our data. So the very first thing that I want to show you is you need to get a Pandas installation. And the best place to get that installation is from here. Conda, pydata.org, mini Conda. You want to take the installation that's actually relevant to the platform you're running on. So if it's 64-bit Windows, 64-bit Mac, or 64-bit Linux, or 32-bit in any case. Download it and install it according to the instructions. So that's the first thing you want to do. The next thing you're going to want to do is set up a Treasure Data API key. And this is done by basically running an export command at the command line. So I'm going to show you how to do that. In fact, I've already done. First off, I guess I should show you where you get the API key from. So let's go back and let's look at Treasure Data Console here. If we go to Treasure Data Console, you've signed up, you've got your Treasure Data account. You go into your profile, and then from your profile, you'll enter your password and you hit Show Keys. And the key that you're interested in is going to be your master API key. Now, I'm not going to show you this here for obvious reasons, but that's how you would get it, right? So let's go back. Then you're going to write a simple export command. So if I show you, it's going to look basically like this. You could do, for example, like this. And then in quotes, you're going to have the string that is your API key. So the command is going to look something like this, right? Now, I've already entered mine and stored it. So I've installed Condas. I've got my Treasure Data account up. I've installed my API key. So let's look at actually creating a virtual Python environment in which to run our IPython notebook. So the first command is going to be conda create -n. And we want Python version 3, right? So we're going to hit this. We want to install the dependencies when it prompts us, so we'll do that. Great. We've created an environment called analysis, so let's activate it. And now this shows that we're running in our analysis virtual environment, right? So we'll want to install a few more dependencies before we get going. So we're going to install Pandas using the conda install command. We're going to install matplotlib, which is basically our plotting library. Again, we say yes to all the dependencies. Clear that out to get a full screen. Lastly, we're going to install IPython Notebook. This will give us some more dependencies we need. So we take those, and then we're good to go. Almost. We also need to install some general Python libraries, which is pandas td. That is our pandas treasure data connector. So let's do pip install pandas td. Great. So now we've got all of our dependencies available to run. And let's create our first notebook. So from our analysis environment, which we've just set up, we type IPython notebook. And this is going to open in a web browser. As I said before, this is a web application. It's running locally on our machine. And this is actually browsing my whole directory structure here, so never mind that. What we're going to do is we're going to create a new IPython notebook. So we just go to New, we go to Python 3, and now we've created a new notebook. And you see that we have our first cell open and ready to take commands. So let's get it set up. What we're going to do is we want matplotlib to run in line. We want to run a few import statements in Python, so we have everything there. And we're going to set up our connection to treasure data as well. So let's do that right now. So matplotlib inline. We're going to import our OS so we can read our environment variable. We're going to import pandas as PD. And we're going to refer to that as a PD variable coming up in the future here. Import pandas underscore TD as TD. Great. Now what we're going to do is we're going to initialize our connection to treasure data. Incidentally, this IPython notebook will be available for you after the webinar is over. So we will capture everything. Let's create our connection. So we're going to point to our API key, which we've stored as an environment variable. So let's do that. We called it master API key. We're going to do endpoint equals, and our endpoint is treasure data API. So https api.treasuredata.com. Right. Now let's do shift and enter. Brings us to the next cell. Right, and we've got an error already. So what is our error here? This will explain to you actually one of the things that it's possible to do, and that is to go back and actually fix the problems as they come up. So you're getting a problem right now with our master API key, which is very interesting. Let me see what we're doing wrong here. Oh, okay. So this will give you a demonstration of when you do something wrong, you can always go back and fix it, right? So let's do this again. I think that was the name of our variable. Right. Now we have some tables we want to look at on treasure data. We want to be able to look at our sample data sets and see what's in there. So if we actually go to the console, we can see what there is. We go to our databases and we go to the console, sample data sets. We see that there's actually two tables here. So we have an application that's basically send events based on when NASDAQ makes a trade. We have another weblog here. So let's look at the NASDAQ data in our IPython notebook. We'll be querying it right on treasure data. So let's go look at that. Right. And I'm going to use con tables sample data sets. So we basically query the table. And it's going to show us the same table list that we saw there. So we see we have worldwide web access, 5,000 rows, and we have a NASDAQ with 800. It looks like 8.8 million rows. We want to set up our query engine. We're going to use Presto. So let's set up a variable called engine using our Presto engine. So great, we set up our query engine for Presto. What we're actually able to do is go back to the same cell and continue editing, adding commands under that. So I want to get the first 3 lines. And I want to convert time to the date time index. So let's do that as well. Right. And you see that comments work the same as they would otherwise work in Python. So read, we're going to use treasure data. That's our pandas TD connector. We're going to use a read TD table from that to actually read our table. So we're reading the NASDAQ table. We're going to use our engine, which we configured just a second ago. We're going to limit this to 3. We're also going to do is we're going to set our index column equals time, and we're going to run a parse date feature as well, and we're going to parse it around these values here using this. Great. So if we do a shift and enter, we should be able to see the first. It takes a while to run the query, but then we should be able to see 3 rows with 3 symbols. So that's great. Hopefully you're beginning to be able to see how flexible and useful this is. We've got all of our data on treasure data. We're querying it. We're running analyses on our treasure data right from within our Jupyter notebooks. Let's keep going. We can also use a time range parameter to retrieve data within a specific time range. So let's get all the rows from the first month of 2010. So we go to our next cell. Right. And what we're going to do here is we're going to create a variable called df, and this is a pandas data frame, right? So that's a variable from within pandas. We can basically store our values into a data frame, and then we can analyze the data frame and plot the contents of the data frame. Very basic concepts to data frames, to pandas rather. Data frames are not only in Python pandas, they're also a common feature in R programming for those of you who are familiar with R. So let's create our data frame, td read td table. We're going to do NASDAQ again. We're going to use our engine. This time, no limit. Time range equals 20100101. Oops, I think we need to put that in quotes. Right. 2, 1. Great. That's the next part. And then we're going to use our index call time. We're basically going to take the rest of this from up here and just copy and paste it down here, right? And if we do Shift Enter, it's going to run some analysis. Oops. So it's actually running the analysis, but it hasn't returned anything, right? So what we want to do to get it to return is we want to plot the data we've got. So we've just returned the data frame, and we can see the job as it ran on treasure data below us here in the notebook. So let's add a plot command to this cell to show what it looks like plotted. Let's plot the sum of volumes grouped by time where index level equals 0. And let's do df group by level equals 0 dot volume sum, and then finally plot. Right. Shift Enter. It's going to run that job in the background again because it's running all of the instructions in this cell, and we should get under here a nice plot, as you see. So we can see how that volume of trades looked on our NASDAQ index during the month of January of 2010, right? Now, a few other things we can do that are really fun and interesting and data science-y is we can sample our data. So as our data set begins to grow very large, the method from the previous step doesn't actually scale very well. It isn't actually a very good idea to retrieve more than 1 million rows at a time because you're going to have memory limitations, you're going to have network limitations. So if you're analyzing a large amount of data, you need to be able to limit the amount of data getting transferred. And there are a couple ways to do this. First, you can actually take a sample of the data. So we know, for example, that the NASDAQ table has, I think we checked it earlier, it has 8,807,278 rows. And sampling 1% of this is going to result in around 88,000 rows, which is pretty reasonable size to retrieve. So let's do a 1% sample. Great, so we're going to do df td read td table. Again, it's NASDAQ. It's going to be our engine. We're going to limit to 100,000. Great. And we add our sample parameter equals 0.01. And then we're going to do the same thing that we did up here, which is take our index column and our parse dates as well. Just going to copy those, paste those down here. Great. And to see how many records we have, we're going to run a len command. So we're going to do length of our data frame. Shift Enter. Give it some time to process. It complains that time index filtering is not set on, but never mind that. We get those sometimes. So great. We see that it's 87,670. So that is approximately 1% of our data set, which makes sense. So that's a reasonable size. There's another way we can sample this, so we can get basically a smaller version of our data set, and that is to write an SQL and actually limit the data from the server side. So for example, if we're interested only in data related to AAPL, the symbol AAPL, let's count that number of records, right? So that's going to look like this. We're going to give ourselves some space in the middle so we can actually type our query. It's a simple count from NASDAQ where symbol equals, oops, right. Oh yes, and we always want to add our engine as well. So let's do that. Let's give it some time to run. And that's going to give us the same situation as before. And great. So it's 8,522 records where the symbol is AAPL. So we know that this is small enough, so we can start to analyze this. Now, what actual fields we want? If we weren't connected to treasure data or we're doing everything natively through the notebook, we wouldn't be able to check this, but let's just do a quick cheat and go over here and check, see what we have. So if we go to, for example, our query window here, and we jump over to sample data sets, and we go to NASDAQ. Okay, I see that I have a time that I can do, and I have open, volume, high, low, and close. So let's do time and close, and let's plot that. So let's go back here. Right. Let's make a new data frame. Read, oops, td, read, td, query. Select time and close from NASDAQ where symbol equals, symbol is AAPL. Great, and we go with the next line. We add our engine. We do our index column again and our parse dates. Right. Then we're going to do a df plot. And we should get a plot soon. Again, we don't have time index filtering set on. So this would be an optimization you could make, but as you see, it's only costing us a few extra seconds. And there we go. There's our plot. So that's the demo. I want to talk to you guys really quickly about how some of our customers are running these things together. So I can't give you names. I can talk to you a little bit about how basically a number of our customers are already running Jupyter and Pandas together with treasure data. So a typical case study looks something like this. Our user is collecting the data from their applications and they're pushing it to treasure data. The analyst is using Jupyter and Pandas to interact with and analyze the data, like you just saw, but they're running machine learning algorithms directly on treasure data through HiveMall, controlling it all through the Jupyter Notebook, and then pushing that data back to treasure data. The user can also run the visualization in Jupyter as well. So they don't have an extra visualization like a Tableau or a Chartio or anything that they're adding. They're doing all their visualizations in the Jupyter Notebook like you saw. Now, Jupyter doesn't do the heavy lifting, and it doesn't transfer large amounts of data. It's simply only your interface. It's sort of your control panel to the data in treasure data. So all of this new data is then moved from treasure data to, for example, a MySQL, or then maybe it goes to Chartio or some third-party place where it's visualized or where further analytics are done. And these databases can then feed back into the application with the insights that they get. So that's how, in a nutshell, we're collecting the data from the users, we're storing it in treasure data, we're analyzing and visualizing the data using Jupyter and Pandas, and we're feeding it back into our application. So what's the call to action here? Well, you're going to want to get treasure data. You're going to want to get conda, mini condas like you saw, Pandas, Matplotlib, and Jupyter Notebook, like I showed you. And then you're going to install the Pandas TD connector. Now, when this is over, we're going to have soon available also videos how to set all this up. We're also going to be coming out very soon with basically a Jupyter cheat sheet. So everything you need to know to get up and running on Jupyter and Treasure Data in a few minutes. So on that note, we've got time for questions. Do we have any incoming questions coming in?
Yeah, hey John, thanks. So, actually, pretty good question. I know that we've got a number of customers using this. Some of them are not necessarily wanting to advertise or be advertised, but how many customers on average are using right now Jupyter with Treasure Data?
That's a good question, actually. You know what? That's one of the ones that I would actually have to come back to because I don't know the exact number. That is a very good question.
Okay.
I'm sorry I don't know the answer to it.
No problem. So is there anything on the roadmap for Jupyter support for Treasure Data?
So we're planning to improve the workflow management side of our platform. We know that many data scientists out there already love Jupyter because it allows them to save and organize their work in progress. We hope to incorporate some of that into Treasure Data as well, possibly with tighter integration in Jupyter.
We'll be following up with everyone with emails and resources, including, John, I believe there's a cheat sheet that you're making, right?
Yes, we're going to make a Jupyter cheat sheet, so how to get up and running very quickly on Jupyter Notebooks in 5 minutes or less. We're also going to have an installation video, so I'm going to walk through the installation and setup steps in a short video as well.
Fantastic. And just because I think it's important to mention, if you do download the Treasure Data 14-day trial, it is free. You can check out how all this stuff works, and how you can collect all your data, push it out to different sources. Just wanted to iterate that because if you do want to test this out, we don't want you to hesitate because you have to pull out a credit card or something.
Right.
All right. Well, thanks very much, everybody. Have an excellent rest of the day, and stay tuned for more on our webinar series.
All right. Thank you.